You are late. You are late. Bismillah, Shabab. 3.2 is about the product and the quotient rules. But before talking about 3.2, let's remember what we had in 3.1. Do you remember? 3.1 it was about what? It was about the derivatives of the polynomials and the derivatives of the exponential function. What we have learned in 3.1, the derivative with respect to x, the derivative of any constant is what? Hello?
Zero.
Zero. The derivative of x with respect to itself, it is what?
1.
1.
Aha, it is 1, yes. The derivative of x to the power n, it is n x
Minus
to the
1.
power
And x to the power minus 1. Yeah.
the derivative of e to the power x, it is e to the power x. Also, we have studied that the derivative of c f of x, if you differentiate a function multiplied by constant, it will be what? C multiplied by the derivative of that function. For example, if you have the derivative of cx, whatever c is, a constant, it will be c, because the derivative of x is 1. Also, we have studied that the derivative of the sum or the difference is the sum or the difference of the derivatives. So this is, of course, we are using a Shabab here the Leibniz the Leibniz notation. Of course, it is easier to use the Newton notation, but of course it is not better, because this will prepare. This is better, ya Shabab. It will prepare you for Math 102. So if we have f plus g and you want to differentiate this, we mean here by this you will differentiate with respect to x. It will be f prime of x plus g prime of x. If it is difference, it will be difference. These are the most important issues. Also, we have studied the normal line. What we mean by the normal line, you know that it is the line that is perpendicular to the tangent line. Now you should make your own table, ya Shabab, of derivatives. Please do this at home. What you need to do, just make a table and add it, update it every day. If you have here, right here, just the function, and here the derivative of the function. So what is the derivative of the function? If the function is constant, the derivative is 0, and so on. So please have your own table of differentiation formulas. Now the product rule, first of all, you should notice that the derivative of the product is not the product of the derivatives, and you will see why. So again, if you have the derivative of f of x times g of x, this is not the derivative of x, the derivative of f times the derivative of g. You cannot distribute the derivative over the sum. The same for the division, the same for the quotient. If you have f over g, the derivative, it is not the derivative of the denominator. Let me write it here, this mixed. It is okay like that. So they are not like that. So be careful. This is not true. What is true is that the derivative of the product is the derivative, the first one multiplied by the derivative of the second one plus the second one multiplied by the derivative of the first one. For the quotient, the derivative of the quotient, it is the first one, or the one in the denominator. Let's say the denominator multiplied by the derivative of the denominator minus the denominator multiplied by the derivative of the denominator over the square of the denominator. Why? We will see. It is by the definition. It obtains from the definition. This is what we are going to call the product rule. F and G both should be both differentiable. In words, I'm going to mention it later. Now, how to prove it? There is a proof in your book. I advise you to go and see the proof in your book. But I have an easier proof. Yes. Please, ya Shabab, mute yourself, please. Ya Shabab, mute yourself unless you want to ask or you want to answer. The proof, ya Shabab, I have a very short and easy proof. How to prove it? You need to use the definition. You know, this is my function. So the derivative of this function will be this function minus the value of the function at t minus x. And this is when you want to, you can use the another definition with limit t, h goes to 0, if you remember that definition. It will be f of x plus h times g of x plus h minus f of x g of x over h when h goes to 0. It is similar to this one. Now, most of the tricks that was in online assessment number 1, it was about this definition. So now what we have, what we can do now, we will do a nice trick, very small trick. We will add 0, but not any 0. We will add this 0. We will add f of t times g of x. So we will add it and subtract it. This is 0, so I didn't change the value of the expression. Now what I'm gonna do later, I'm gonna take f of t here as a common factor, and here I'm gonna take g of x as a common factor. So look what I will have. Here it will be the common factor, this will be here a common factor, distribute over the same denominator. Now if you distribute the limit, if you take the limit, this will be what? This will be f of x, if t goes to x. Now what will be this? When you give it the limit, when the limit of this will be what?
0.
The
derivative.
derivative of g. You know that according to the definition of the derivative. And again, if you distribute the limit here, you will have the same function again. And if you give the limit here, it will be the derivative of f. And that's it. So we proved the product rule. In words, what the product rule says, it says the derivative of a product of two functions is the first function times the derivative of the second function plus the second function times the derivative of the first function. And if you said it like this, f g prime, so you can just remember it like this, f g prime, it is f g prime plus g f prime. Okay, I usually prefer to write it this way, but it is the same. It is f g prime plus f prime g. Is there any problem if I did that? No, the product is commutative. So I will make always f at the beginning and g at the end. So first f, then the derivative of g, then f prime g. It is okay, use this or this equivalent. طبعا there is another notation. طبعا if you put u equals f and v equals g, so you will have it in this short way. The derivative of uv, u here, it is a function of f of x, and f is a function of x. So it will be u dv dx plus v du dx, which is the same. This is the same, but just here both v, here both u. Example 1. We have here x times e to the power x. Find the first derivative. What will be the first derivative? You can notice that we have a product of two rules. It is a common mistake, ya shabab. X e to the power x. Some of you, they said the derivative of x is 1. The derivative of e to the power x, it is e to the power x. So the result is e to the power x. Is that correct?
No, we cannot distribute.
No. We have a product now, a product of two functions. So we have x and e to the power x. So now what you will do, you will apply the product rule. So the product rule says what? It will be the first one multiplied by the derivative of the second, plus the second multiplied by the derivative of the first. Now it will be x times, what is the derivative of e to the power x? It is e to the power x. Plus e to the power x times the derivative of x with respect to x, it is 1. Simplify e to the power x multiplied by 1, it is e to the power x. That's it. Take e to the power x as a common factor to simplify. So this is the derivative, ya shabab. What you can notice, what happened, if you compare it with the original function, it looks like just we add what? It was x, e to the power x. Now it becomes x plus 1, e to the power x. Now this is part A. Part B, find the nth derivative. What does that mean? Second, third, fourth, nth derivative in general for any positive integer n. So what we will do to find the nth derivative, we will find first the second derivative. If you find the second derivative, what you will do, you will differentiate this, the first derivative. So it will be the derivative of x plus 1 times e to the power x. It will be the first times the derivative of the second plus the second times the derivative of the first. طبعا you can skip يا شباب this step, but not at the beginning. You should do it few times before, until you memorize it, until you know how to use it, and then you can skip this step, by the way. Also this step, you can skip this step. Now what it will be, but you have to be sure that you are using it in the right way. So it will be x plus 1 times what? E to the power x plus e to the power x times, what is the derivative of this? It is x. Now simplify. If you simplify this expression, what you will get e to the power x plus 2, because you have e to the power x and here you have 1 e to the power x. You will take e to the power x as a common factor. So you will have x plus 1 plus
Doctor,
1.
the derivative of x plus 1 is 1, right?
The derivative of x plus 1, it is the derivative of the sum of two functions. So it will be the derivative of the first one plus the derivative of the second one. The derivative of x is 1, the derivative of
Yes,
y
yes.
You wrote x.
You wrote x because you wrote x in the last slide.
If I said that, it's wrong.
Yes, so I just want to correct.
1, yes.
Yes,
1,
yes.
It is 1, not x, yes. Here it is. Now, again, this will be a shabab x plus 2, look. Because we have here 1x and here also 1x, so there will be 2x. Now it looks like the second derivative will be the same, just we will add 2. So can you now conclude what will be the third? What will be the third derivative according to that? You have to be sure.
Plus 3.
To be sure, you have to do it again. طبعا, it is better to do the third derivative and the fourth to make sure that you are in the right path. And after that, you can generalize. So the nth derivative will be x plus n. So you can, if someone asks you what is the 100 derivative, what is the 100 derivative of this function? It will be x plus 100 e to the power x. Okay, you can do that, Shabab, for many functions, of course, that they keep repeating the same manner when they differentiate it. Now differentiate this function again. Look at this function. You have a product of two functions. And the second function, it has a plus b. And a here and b are real numbers, any real numbers. They don't depend on t. So their derivative with respect to t will be 0 if you differentiate a, for example, or b or whatever. Now let's come to the product rule. We should apply the product rule. So to apply the product rule, it will be the first one multiplied by the derivative of the second plus the first one the second one multiplied by the derivative of the first one. You can skip this step if you are sure about it. You can go to directly this step. You will write the first one multiplied by the derivative of the second one. The derivative of a, it is 0. The derivative of bt, it is b. And it is clear, Shabab, it should be clear for you why the derivative of dt, it is bt by the product, the constant multiple rule. The b will go outside, so it will be b multiplied by the derivative of dt, so it will be multiplied by 1, so it will be b. Or you can think about it as a product also. So this is a product of two functions, so it will be the first one multiplied by the derivative of the second one, which is 1, plus the second one multiplied by the derivative of the first one. What is the derivative of the constant? 0. So this will be 0 and this will be b, and you have b at the end. So you can look at it as a product, or it is easier to look at it using 3.1 as a constant multiple of another function. Now simplify your expression. Now we still, the derivative of this is a, is b. I said the first one multiplied by the derivative of the second one, it is b, plus the second one multiplied by the derivative of square root of t. And you know what is square root of t, Shabab? Square root of t, it is just t to the power a half. So when you differentiate it with respect to t, it will be a half t to the power a half minus 1, it is negative a half. Here it is, which you can write, of course, as 1 over 2 square root of t. Now this is the derivative of the second. Now it is a matter of simplifying. Be careful. This will be b square root of t, and this will be p a plus bt over 2 square root of t. You can stop here and you can simplify more if you want. You can just make them a single fraction, by writing them over the same LCD. It is just a matter of algebra after that. Now, this is one solution. As you can see, this is solution number one. There is a better solution. In my opinion, this is long. I have a better solution. What? I can solve it without using the product rule. How? First of all, I will simplify. This is, of course, very important trick here. You should always think about it to save your time. So now what I'm gonna do, before taking the derivative, I will write this as just t to the power, it will be t to the power a half multiplied by a plus bt. So I'm gonna write it like a multiply, it will be t to the power a half plus b t to the power 3/2. Here it is. Distribute before. Now it is easy. How to differentiate? You will multiply by the power and subtract 1. So it will be just a multiplied by a half, t to the power negative half. B multiplied by 3/2, t to the power 3/2 minus 1, it will be a half. Now simplify, you will have this there immediately. Okay, so if you simplify, it will be a over 2 square root of t plus 3b over 2 square root of t, which is the same. If you notice, it is the same as this one, but you need to simplify.
Doctor,
Yes.
I have a question. Why here we put 3/2?
What is the derivative of t to the power 3/2? What is it, Abraham?
We minus, okay.
3/2 t to the power 3/2 minus 1, which will be 3/2 t to the power a half.
Doctor,
Yes.
can I distribute if there was absolute value?
No, you should remove the absolute value first. Write the expression without absolute value. You can distribute, of course, if you have this absolute value, it will be, you can distribute, it will be a absolute value plus, but what is the benefit of distributing the absolute value? You have a problem with one absolute value. It will be more if you have two absolute values. Now, another kind of questions, when you have this type of questions, you have square root of x multiplied by another function. Now, if he gave you g at 4 and g prime at 4, and he wants you to find f prime at 4. Very nice trick here. This is the type of questions that you may have in the exam. It is not direct. The previous ones, they were direct. What is the idea? Anyone can help me with the idea of this question? What should we do?
Maybe find
find the derivative of f of x.
Yes. So you want f prime at 4. If you can have f prime of x, you will just substitute by what? By 4. So if you can have this, it will be very easy. I have f of x. Because I have f of x, I can have f prime of x. So what I'm gonna do, f of x, it is a product of two functions. So I will apply the product rule. So it will be f prime of x will be the first one, multiply. You can skip this step, as I told you. This step you can skip. The first one, it will be the first one multiplied by the derivative of the second one, plus the second one multiplied by the derivative of the first one, which is 1/2 square root of x. You should add, ya shabab, to your table. I told you you should have table of derivatives. If you write here square root of x, the derivative is 1/2 square root of x, because we will use it several times. So don't waste your time memorizing what is it. Now, here we are. So this is f prime of x. So what you will do to find f prime at 4, you will just substitute. I think it is here. Yes, it is better than even mine. Now, what you will do, you will just simplify if you want, no need. This is what I did exactly. So now, both now, x equals to 4. Instead of x, substitute, it will be square root of 4, the f prime at 4. It will be square root of 4, g prime at 4 plus g at 4 over t. Now, do I have this? Here it is. Do I have G at 4? Yes, here it is. Just it is a matter of substituting now. So it is 6.5, 13 over 2. Any question, Shabab? Is that clear? So let's go now to the quotient rule. If you have two functions that they are differentiable, then the derivative of their quotient will be like this. It will be the derivative, it is the denominator times the derivative of the numerator. Look, the denominator multiplied by the derivative of the numerator minus, not plus, be careful, minus the numerator times the derivative of the denominator divided by the square of the denominator. Don't forget the square here. The proof is similar, ya shabab, to what I did. If you want to prove it, the same idea, I advise you to do that. You will add and subtract. I don't know, I think I didn't prove it for you here in the slides, but the proof is similar to what I did. You will add 0, but you need to think about what is the best 0 to add. I think it will be, I'm not sure that it will be g of x times f of t, something like that. Now, how to add? Now add to your table. If you should have a table of derivatives, your own table, right there. If you have f over g, if your function it is f over g, what will be the derivative? The derivative will be g f prime minus f g prime over g squared. That's it. Now let's apply it whenever we have quotient. So we have example number 1. First of all, you should notice that you have a quotient of two functions. Can you simplify the expression that it will not be a quotient? The answer is no. Now what you have to do, it is a matter of, you have to apply this rule. Now this is f, this is g. But let me ask you a question. If it is like that, Shabab, if it is x squared plus x minus 2 over x cubed, you can apply the quotient rule, but do you need to apply the quotient rule, or there is an easier way?
No,
there is an easier way.
there is, you can remove some.
You can now write it as x squared over x cubed plus x over x cubed minus 2 over x cubed. Can I do that? Of course I can. Before taking the derivative, this will be x to the power -1 plus x to the power -2 minus 2x to the power -3.
Teacher, where is plus 6?
Sorry?
Where is plus 6?
I said if it is, if we don't have this.
Oh, okay.
If we don't have it. Now the derivative will be easily, it will be negative x to the power -2 minus 2x to the power -3 minus, it will be plus 6x to the power -4. This is if we don't have this. But now, because of this, we cannot write it as a powers. So what we should do now, we have to apply the quotient rule. To apply the quotient rule, remember, it will be the denominator multiplied by the derivative. The order here is important because we have minus here. So be careful. In the case of the product, the order is not that important because we have addition, and the addition is commutative, but the subtraction is not. So it will be the denominator multiplied by the derivative of the numerator minus, be careful when you have multi-terms about the negative sign, minus the numerator multiplied by the derivative of the denominator over the square of the denominator. Now simplify, it will be this multiplied by the derivative, this is the derivative. You can skip this step, ya shabab, but it is there. You have to realize that it is there. And this is this multiplied by the derivative of x cubed, it is this one. Now it is a matter of simplifying. Don't think about canceling. Some of you, they said, let me cancel this, with the power. Be careful, this is not a product. This is, you have two terms here, so you cannot do that. It is wrong. So what you should do now, you should expand, multiply this by this and multiply this by this. It is very important step, algebraic step. Combine the like terms This is what you are going to have at the end. So this is the derivative. If you can simplify it more, simplify, but I think you cannot. You have to stop here. So this is the derivative of this function. Now, let's have an example that is also not direct. We need here to find the equation of the tangent line. Do you remember the tangent line? How to find the equation of the tangent line? It will be at a specific point. So our point here, it is given. So it will be y minus f of a. This is the general formula. F prime of a, x minus a. This is the equation of the tangent line at the point x equals a. We have a here. Our a here, it is 1. So this is 1. Our f of a here, it is a half of e. Now we need to find this. The question is, what is the derivative of the function at 1? To find the derivative at 1, you need to find the derivative of x in general. What is my function? My function is e to the power x over 1 plus x squared. I cannot simplify it or write it in a simpler form. So it is a quotient. I cannot distribute here. I cannot do anything. So what I will do, I will apply the quotient rule. I will say the derivative of the denominator multiplied the derivative of the numerator minus, and so on. So this is how to find the derivative now of this function. Again, you can skip this step, but you have to be sure that it is there. So it is the denominator multiplied by the derivative of the numerator minus the numerator multiplied by the derivative of the denominator over the square of the denominator. Now expand here. Don't simplify, expand. After expanding, if you can factor this, factor it. I think we can. So it is x minus or 1 minus x all squared. You can write it x minus 1 all squared. It is the same because of the square. Now you cannot cancel any terms, so you have to keep it like it is. Now what you need to do, you need to find the derivative of y with respect to x at x equals what? At x equals 1. So this is, I think, what he is going to do. What is this, Shabab? This is the same as f prime at 1. You know, this is the Newton notation. This is the Leibniz notation. So this means this. So what is the value of the derivative at 1, Shabab? Clearly here. What is it?
0.
0. It will be 0 over a number that is not 0. So it will be 0 over a number. Whatever this number is, it is 0. If it is not 0, it is not 0 over 0. It is 0 over 1. What you are going to have here, it is 0 over 1. Why it is 0? Because of this. So don't waste your time calculating the other terms. So the derivative here will be 0. So this one will be 0. So this will disappear. So what we are going to have? What will be the equation of the horizontal of the tangent? It will be a horizontal line, because the value of the derivative at that point is 0. So this means that the tangent line is a horizontal at this point, because the derivative of it is 0, and here it is. So if you have the graph of this function, it will have a horizontal tangent at that point. Any question, Shabab? Is that clear? Let's go now to, yes, I think I've mentioned this before. Don't use the quotient rule every time you see a quotient. Don't use the quotient rule every time you see a quotient. Sometimes it is easier to rewrite a quotient first to put it in a form that is simpler for the purpose of differentiation. Like this. It is a quotient. You can use the derivative. It's okay. You can use the quotient rule. If you want to find the derivative, you can use the quotient rule. But if you notice, what is this? This is 3x squared. I think I have mentioned it here. It is 3x squared over x plus 2 square root of x over x. Simplify. What will be this? This will be 3x, because this will be cancelled with x, and it will be 2x to the power negative half. Now the derivative will be easy. The differentiation will be very easy. It will be just the derivative of this 3x. What is it? 3. The derivative of this one, it is 2 times negative half times x to the power negative 3 over 2. So this will be cancelled, and you'll have negative x to the power negative 3 over 2. You can write it, of course, as 3 minus 1 over square root of x cubed. which is of course x square root of x, because x is positive, it must be positive. And you can write it in the form, if you want, you can write it as 3x square root of x minus 1 over x square root of x, which is similar to the form that you have here. So this is f prime. Again, Shabab, if you use the quotient rule, you should have something like this, similar to this at the end. But of course, it will be a longer solution. This is short solution if you simplify your function first. Don't just close your eyes and start differentiating. Sometimes you can simplify, but be careful, can you or you cannot? Because for example, if this function, it was like this, if it is like this, can you now simplify? No, you cannot here. But what is the benefit? If you distribute, you will still have, instead of one quotient, you have to do it twice. So no benefit from that. Be careful, ya Shabab, here about a common mistake that some students are doing. Ya Shabab, this mistake is coming from this fact, a plus b over c. It is a over c plus b over c if c is not 0, طبعا. But the opposite, if it is a over b plus c, this is not a over b plus a over c. Be careful about this. So,
but can I do it, right?
Yes. Again?
But can I do the differential here, 3x to the power of 2 over x plus 1 plus, in two terms, I mean.
You need to apply the quotient rule here.
Yes, twice,
Quotient
I know.
So you will make it harder, you will not make it simple. So what I mean that, ya Shabab, by the way, you can always differentiate. طالما الفانكشن differentiable, you can differentiate any function. You can differentiate any function. The problem just, is it defined, it will be at specific numbers or not. But of course, we are differentiating function over their domain, so we assume that all the functions that we are working with are differentiable. الزبدة يا شباب, let's summarize what we had until now. This is the table of differentiation formulas. So let's remember what we had in 3.1 and 3.2. The derivative of the constant is 0. The derivative of the power function is like this. The derivative of the natural exponential function. The derivative of the product function with the constant. The sum rule, the difference rule, the product rule, and the quotient rule. I can add here for you, Shabab, something that you need, it will be better to remember, that the derivative of the square root of x, to save your time, it is 2 over square root of x. Add this one to there. You can also add, when you have derivative of a times x, it is a. So because this, we will use them several times. So this will save, of course, your time. And that's it, ya Shabab. This is 3.2. So it is about just two concepts, the product rule and the quotient rule. Let's go now and practice. I don't want to go to 3.3. Yes.
Just one question. Can you re-explain the CF prime? Just really quick.
Yes, we prove it indeed. We have proved this in the previous class, if you remember.
Okay.
Yes, we have proved it. The proof is there. So now if you have a function, if you have c multiplied, if you have, for example, 3 multiplied by e to the power x, when you differentiate it, what you will do? Let's apply the product rule. We have proved this in the previous class by using the definition. Let's prove it here. Let's prove it here by using the product rule. Now you have a product of two functions. So it will be what? It will be the first one multiplied by the derivative of the second. This is the product rule. I'm applying this rule, ya Shabab. Plus the first one multiplied by the derivative of the second, then the derivative of the first one multiplied by the second one. Now c multiplied by this, it will be cf prime. Am I right? Plus, what is the derivative of the constant?
0.
0 multiplied by this function, it will be 0. So this will be 0.
Oh, okay.
What? How interesting it is?
Yes.
So always, ya Shabab, think about it. And please, ya Shabab, don't just about problems you have seen before. I have noticed that there are 2 or 3 questions in the online assessment number 1. Many students, they didn't solve because they didn't see questions similar to it before. This is one of the issues, that you just memorizing the solutions. You are not now improving your thinking skills. So you should think about any new problem that you have, Shabab, by using your old experience. Not by memorizing, no, by analyzing, comparing, and try to just focus on what do you have, what do you want, what you can use. Please يا شباب. لذلك أنا لا أنصح إنه you just look at the solutions always. Most of you, I want everything to be solved. This is not mathematics. If everything is solved for you, you will not learn. I told you that in the first lecture. 3 things. If you did 3 things, you will not be able to solve in the exams. If you just read the solutions, if you just watch someone else solving, if you go to the solutions with the least difficulty, if you did these 3 steps, you will not solve the problems in the exam. If you want to solve, ya shabab, understand the concept very well, and then go and practice. Use a paper and pen and solve. You have to live the situation of the exam. What you are going to have in the exam, for example, you will have a question like this. In the exam, you will have a question like this, and you have 5 options, 5 choices. You don't know which one is the right one. Don't look at the solution when you solve. This is why, Shabab, I put my effort in the slides to hide the solution. You cannot see the solution in the first. So activate the slideshow and then practice. Imagine that you are in the exam now. Don't just try for 1 minute or 2 minutes and after that go and see the solution. No, you should try and try. If you couldn't solve it today, you can solve it tomorrow, no problem. This will improve your skills of thinking, because whenever you will have a new problem, you will be able to solve it. Like here, Shabab, I will give you 2 minutes to solve this, please. 2 minutes, I think they are enough, of 3 if you want. You have x over e to the power x. Find the derivative number 101. What is the 101 derivative? Yalla ya shabab, start. Which rule are you going to use?
Doctor,
Yes.
so now I find the derivative, then substitute by 6.
This is the idea, of course. Do you have another idea?
And
Is there another way?
101, what should I do with it?
No, I mean, if there is another way, can you tell me about it? So I will give you, Shabab, as I said, 2 minutes. Raise your hand, please. Raise your hand, Shabab. All of you, raise your hand, please. Let me just call this guy. I don't know what, he might be a student. Raise your hand, Shabab, please. His hand, ya Shabab. Where is Abdul Aziz Asiri, Ahmed Zahrani, Ahmed Al Jaber, Ahmed Al Shouq, Hamad Ahmar, Umar Al Mutayri.
الجبر موجود.
If you didn't raise your hand, I will consider you absent. Raise your hand.
Okay.
For the last time, يا شباب, raise your hand. عبد العزيز عسيري, حماد, عمر المطيري, raise your hand. If you didn't raise your hand, يا شباب, the three guys that I'm calling, عبد العزيز عسيري, حماد, and Umar, you are not responding, so you are absent. That's it. Okay. So what is the answer, يا شباب? Let me launch a poll for you. Polling.
Doctor, lower our hand or
Lower your hands now. Thank you. Lower your hands. Thank you. Choose your answer يا شباب. Oh, no, you didn't agree about any answer. Let me end. Oh, we don't have time to that. Look at the solution يا شباب. Look at the responses. 6 with A, 8 with B, 2 with C, 3 with D, E with 4. You didn't agree about any answer. So you are guessing. You are just guessing. It looks like you don't have the solution. The answer is A. في حد من الشباب حق A.
Yes.
He finished solving this?
yes,
I did.
So what you will do يا شباب, first of all, you will find the first derivative. First of all, you will find the first derivative. What is the first derivative?
1 minus x over e power x.
So first of all, what I advise you to do يا شباب, what you will do, you will apply the quotient rule. Am I right?
yes, you have to apply the quotient rule.
I have a better idea. I will write the function itself as x e to the power negative x. It will be now easier to use the product. You know, Shabab, that the product rule is easier than the quotient rule.
Yes,
So
also.
now, the derivative now will be what? The first one multiplied by the derivative of the second, which is the same, but plus the second one multiplied by the derivative of x, which is 1. So this is the first derivative. Sorry, minus. So it is the, let me repeat it. It will be the first one multiplied by the derivative of this, which is negative. Because here we have e to the power negative x. What is the derivative of this? The derivative, Shabab, is e to the power negative x, but with a negative here. And this is, by the way, the chain rule. We didn't study it before. So I advise you here to use the quotient rule because you don't know how to differentiate this. The derivative of this, it is the same, but you need to consider the derivative of this. This is a 3.4. We will study it in 3.4. So I'm gonna use the quotient rule. Unfortunately, we cannot use this because it is easier, but you didn't study the quotient rule yet. So it is x over e to the power x. Now the derivative will be what? The first derivative will be e to the power x all squared, which is e to the power 2x. Okay? And here what you will have the first, the denominator multiplied by the derivative of the numerator minus the numerator multiplied by the derivative of the denominator. This is the first derivative. You can simplify it, Shabab. Before going to the second derivative, simplify. Take e to the power x as a common factor. You will have 1 minus x over e to the power 2x, which is e to the power, which is 1 minus x over e to the power x. This is the first derivative. Now find the second derivative, and then find the third, and try at the end to find the derivative, the nth derivative, to have a formula for the nth derivative.
I got it actually.
Who find the nth derivative, the form for the nth derivative, Shabab?
Me.
Yes, what is that?
Minus 1 to the power of n.
Minus 1, what is that? Minus 1.
Sorry, n minus 1.
Okay, minus 1 to the power n.
Times x minus n.
X minus n.
N.
All over
e to the x.
E to the power x. So this is the nth derivative, Shabab. I will check that. We will check that. Do we have time? We can solve it. So let's continue now. The second derivative, Shabab, for this. Let me do it here. So the second derivative will be what? will be again the denominator squared, the denominator multiplied by the derivative of this, so it will be e to the power x multiplied by -1 plus the derivative, the 1 minus x multiplied by e to the power x, minus, not plus. So now simplify the second derivative. What you are going to have? You have e to the power x as a common factor. It will be cancelled with the one in the denominator. And here you will have -1 plus 1 plus x. Is that right? And this will be x over e to the power x. What is wrong with that?
No, it will be -1 minus 1 also.
Let's check again the second derivative, Shabab. The second derivative is the square of the denominator. The denominator multiplied by the derivative of this, which is -1, minus the numerator multiplied by the derivative of the denominator, which is itself. Now take this as a common factor, cancel it with the one in the denominator, you will have e to the power x. Now here you have -1. -1, it will be -2 plus x. You are
Yes.
right? So it will be x minus 2.
Yes.
So no need, I think, for this. So I think we don't need it. It will be x minus
no.
x. Let's
We have,
check.
because the first term was 1 minus x.
Check the third derivative. You can now apply the third derivative. It is expected to have x minus 3. Let's see that, ya shabab. The time is up. You can leave if you want. You can leave, ya shabab. This is the end of the class. And of course, you can find the third derivative. Let's find the third derivative. The third derivative now will be what? E to the power 2 squared. It will be the denominator multiplied by -2 plus or minus, sorry, x minus 2 e to the power x. Take e to the power x as a common factor. Cancel it with that. You will have -2 negative x plus 2.
Cancel 2 with 2.
Plus x minus 2. Yes.
No, it's not -2.
Minus 2.
The first term, it's e to the x times 1.
1, yes. This is 1. So this is 1, and it will be a shabab 3 minus x. And because of that, we will need this. Yes, you are right. So this is the nth derivative. Yeah, shabab, this is the nth derivative. It is correct. We have made sure about it. So it is here it is 1 minus x. Here it is x minus 2. And now here it is 3 minus x. So it will be, when it is odd, it will be negative. When it is even, it will be positive. Now you will do what? You will just substitute by what? By 6. And n by 100. So the derivative, the 100 derivative of 6 will be just -1 to the power 100. So it will be negative. X, it is 6 minus 101 over e to the power 6. Now 6 minus 1 over 100, it will be negative, it will be positive. 100, when you subtract 6 from it, it will be 95. This will be in the denominator, so it will be e to the power -6. Here it is. There are, shabab, many old exams that you can practice and solve. There are many for the last 3 years, they are here. For the ones before the last 3 years, you can go and to the website and to practice them.
Teacher, won't be the next quiz.
Now because I have another class. Yes, do you have a